Assalamualaikum. My name is Nur Shafika binti Amrin, and you guys can call me as Shafika Amrin. So today I'm going to present an article about the Internet of Audio Things, state of the art, the vision, and also the challenges. All right. So for the introduction, what is actually the Internet of Things or IoT? So first, the Internet of Things, IoT, is a network of interconnected computing devices, mechanical and digital machinery, items, animals, or people with unique identifiers, UIDs, and the ability to transfer data without requiring human to human or human to computer interaction. But now, what is IOMUST and what is the connection with the audio? So first, IOMUST, or we call Internet of Musical Things, mostly focus on human consuming musical applications such as concerts, music productions, music pedagogy, and so on. Right, next. State of art in the audio things. So first is wireless acoustic sensors networks. Acoustic array processing is today an essential part of many applications involving the analysis of audio signals such as hearing aids, hands-free devices, or immersive audio recording. While a number of acoustic sensing and processing systems have been proposed over the last decades, these have typically relied on high throughput computing platforms and or expensive microphone arrays. Although microphone arrays yield a higher performance than single microphone systems, some limitations arise from the fact that the position of the microphones tend to be fixed and all the signal processing tasks are performed on a centralized processor. The alternative is to use comparatively low resource distributed nodes with sensing devices and algorithms aimed at detecting, localizing, or characterizing acoustic events. The advantage of this system is that the wireless, battery-powered nodes are less expensive and can be easily deployed in a wide range of environments. Moreover, opposed to the traditional microphone arrays that assemble sound field only locate distributed acoustic sensing systems allow using many more sensors to cover area of interest. Next is acoustic data transmission. So, acoustic data transmission or ADT forms a branch of the audio data hiding techniques with its capability of communicating data in short range aerial space between a loudspeaker and also a microphone. So, to achieve a good trade-off between the audio quality and the data transmission performance, the enhanced segmental SNR adjustment (SSA) algorithm is proposed. Multi-microphone ADT technique further enhances the transmission performance while ensuring compatibility with a single microphone system. And the last one is the semantic audio. Semantic audio is the extraction of meaning from audio signals. The field of semantic audio is primarily based around the analysis of audio to create some meaningful metadata, which can then be used in a variety of diverse ways. The semantic web provides a powerful framework for the expression and reuse of structure. The use and storage of semantic audio descriptors in the semantic web frame allows for a much greater reach and unifying standard for storing and many associated semantic audio metadata. Next, we'll focus on audio things. Okay, audio things are entities that can be produce audio content or to analyze phenomena associated with auditory events and can be connected to a local and or remote network and act as a sender or a receiver. An audio thing can be, for example, a node in wireless acoustic sensor network WASN or a device responding to a user's gesture with auditory feedback or any other network device utilized to control, generate, or track responses to auditory content. We position audio things as a subclass of things, therefore they inherit characteristics of things in the IoT context, such as sensors, actuators, connectivity options, and software to collect, analyze, receive, and transmit data. Next, connectivity. The IOAUT, or Internet of Audio Things connectivity infrastructure, supports multidirectional wired and wireless communication between audio things, both locally and remotely. The interconnection of audio things over local networks and or internet is achieved by the means of hardware and software technologies as well as standards and protocols governing the communications. The last one of concept and vision is applications and services. Several types of applications and services can be built on top of the connectivity, targeting different users according to the purpose of the audio things, such as human agents monitoring events, patients, and also doctors. Such applications and services may have an interactive or a non-interactive nature. To establish interactive audio applications, real-time computations have particular importance. Analogously to the IoT field, the IOAUT can leverage web APIs and Web of Things architectures. Audio things via web APIs can expose services, applications as part of a higher layer in the Web of Audio Things architecture, letting users interact with content or audio things directly. Next is challenge. First, machine analysis of audio content. The first detection and classification of acoustic scene and events challenge was launched in 2013. Large amounts of recordings have fueled research on the use of machine learning to gather high-level information about the sound environment. Non-negative matrix factorization techniques are well suited for the acoustic event detection task. Second, privacy and security challenge. Other things can automatically collect, analyze, and exchange data related to their users. Transparent privacy mechanisms need to be implemented on a diverse range of audio things. Security risks also come from hardware hacking. WASNs can be extremely useful to gather rich information about different aspects of the quality of life in urban areas. Even if speech is a weak biometric indicator, the information gathered using WASNs must not contain any speech information that could be used by humans or computers. Challenges is synchronization. So distributed computational resources need to be synchronized in time. Third, the degree of precision to which this synchronization shall be is application dependent. Quality of service is ensured by minimizing the following conditions, like the variance of the difference between the local time of each node and that of its neighbors. NTP assumes that computational and network resources are cheap. While this may hold for traditional networks, it may not be the case for low consumption sensor networks. When there is a need for every precise synchronization, the precision time protocol PTP can be considered. Next. Last one, for the conclusion, summarily, the IOAUT, Internet of Audio Things, relates to wireless networks of smart devices dedicated to audio purpose. It allows for various forms of interconnection among different stakeholders in both co-located and remote settings. The success on this field strongly relies on standardization requirements which are currently unmet. This article presents a vision for the IOAUT, highlighting its unique characteristic in contrast to the IoT. It also identifies the major challenges and requirements to realize it. That's all from me, Shafika Aminuddin. See you next time. Assalamualaikum.